Okay, we're going to look at something called radians. Now, a radian is, let's take this down just now, a radian is an alternative unit of measurement for the size of an angle. For the size of an angle. Okay, now, if you think about the units that you've used to find the size of an angle, there's only been one, which is a degree. All right. Now, if you think about what's a degree, well, 360 degrees makes up a full turn. So 1 degree then is just 1/360th of that. Right. So if we were to say that that was 1 degree, then we would to 360 of these would make up a full turn in a circle. All right. So that's a degree. Now, if you think about different units of length, you're well used for a lot of years now of using different units of length to measure things. So that might be a metre, it could be a foot, it could be a furlong, a mile, a kilometre, a millimetre, a centimetre. Now for angles though, you only tend to use degrees up to now. But now we're going to look at something called a radian, which is an alternative measurement for the size of an angle. All right, now what is a radian? What size is it? Let's cover that just now. Now, what I want you to imagine is we've got a circle and that we've got the centre of the circle and we've got a radius of the circle. So I'm going to call that radius R. Now, what I want you to imagine now is that we take that radius and let's imagine that that was a string. And what we do is we get the string that's the same length of the radius and we wrap it around the circle. So wrap it around the circle so that it's tight. Okay, and then the length of that is R again. Okay. Now, next thing to be thinking about is what's the circumference of the circle? The circumference of the circle is pi times the diameter, and another way of writing that is 2 pi R. Okay. So, what does that mean? That means the circumference of the circle is 2 pi lots of the radius. Now what's 2 pi? 2 pi, well that's roughly, so I'm going to bring in this almost equal, see that kind of squiggled equal sign? That's almost equal. So that's almost equal to 6.2 lots of the radius, because pi is equal to 3.14, so 2 pi is 6.28. So the circumference then is almost equal to 6.28 lots of the radius. Okay, so what does that mean? Well, if you get the radius and you multiply it by 6, that will roughly give you the circumference of the circle, but an even more precise one would be it's about 6.28 times. All right. Now, what does that mean? That means that this length here will wrap around this circle. From here to here, it will wrap around the circle 6.28 times. Okay. Now, if we create a wedge inside there, that angle, we would call that angle 1 radian. And that is the measurement of 1 radian. So what is it again, right? So you've got the radius of a circle. You then take that radius and you wrap it around a circle. You pull it tight, but it's a piece of string, imagine, so that you can manipulate it and curve it. So curve it around the circle, and it's still got a length of R. The circumference of a circle is pi times the diameter, which is pi times the radius times 2, is 2 pi R. 2 pi is about 6.28, so that means roughly the circumference of the circle is about 6.28 lots of the radius. Okay, and if we think about that slice of the circle, the angle that's created within the centre, we would call that 1 radian. Now, just to give you an idea of the size of a radian, 1 radian is approximately, not equal to, but approximately equal to 57 degrees. Okay. Now, how many times will this radius, this piece of string, wrap around the circle? Well, it will wrap around the circle about 6 times, but a bit more precise than that would be 6.28 times, and then the exact value would be then it wraps around it 2 pi times. So 2 pi lots of 1 radian is equal to the full turn of the circle. Okay, so the full turn of the circle being 360 degrees. So we can short that down and say 2 pi times a radian. 2 pi radians is equal to 360 degrees. Okay, so in this case then R means radian. Okay, 2 pi radians is 360 degrees. Okay, now in higher maths what we can do is we can just shorten that down and pronounce it as that. So 2 pi radians 360 degrees and pi radians is 180 degrees. So just stick with this just now, alright? I might have lost you a wee bit. Don't get confused with it, just stick with it. Pi radians is 180 degrees. 2 pi radians is 360 degrees. Okay, now there's certain ones that we want to know. We want to know that 2 pi radians will be 360 degrees. Pi radians is 180 degrees. Okay, pi over 2 radians, 90 degrees. Pi over 3 radians, 60 degrees. Okay, this is all worked from the fact that 2 pi radians, so 1 radian will wrap around that circle about 6.28 times, about 2 pi times. So 2 pi lots of a radian brings you around the full circle, 360 degrees. Well, if 2 pi radians 360, then pi radians would be 180. Pi over 2 radians is 90 degrees. Pi over 3, 60 degrees. Pi over 4 then would be 45 degrees. And pi over 6 is 30 degrees. Okay, so those are ones that we really want to be known off by heart. 2 pi radians is 360, pi radians is 180, pi over 2 radians is 90 degrees, pi over 3 radians 60 degrees, pi over 4 radians 45 degrees, and pi over 6 radians is 30 degrees. Okay, now let's say I was to ask you to find then cos 2 pi over 3, and I said find the exact value. Okay, so first of all, pi radians is 180 degrees. So what we can do is we can start to think about this as if it was degrees. So cos 2 pi over 3 is equal to, well, pi radians is 180. So 2 pi radians is 360. 360 divided by 3, that would be cos 120. Okay, so dead easy. Pi is 180. Pi times 2 is 360. 360 divided by 3, that's 120. Cos 120. Now, as soon as I've got to cos 120, I can go to today's work, which is to get the exact value using the cast diagram. Okay, so 0 to 90 to 120. Okay, we're in the sine quadrant. Cos is negative in the sine quadrant. The acute angle is 30 degrees minus cos 30, and my exact value, which I should have picked up by now, cos 30 is root 3 over 2, so that's minus root 3 over 2. Okay, let's try another one. Let's go for sine 3 pi over 4. Okay, pi radians is 180 degrees. Now, hopefully by this point you've picked up the fact that once you've established what a radian is, you then just need to learn some of these things off from heart. So pi radians is 180 degrees. So sine 3 pi over 4 is sine of, well, 3 pi over 4, well, pi is 180. Now, what's pi over 4? 180 divided by 4, that's 45. So there's pi over 4, 45, times that by 3, sine 135. So you look to make the transition between radians into degrees. Okay, so let me just go over that again. Your base then is pi radians is 180 degrees. So pi over 4 is 45, because that's 180 divided by 4, so it's pi over 4, 45, times that by 3, 45 times 3, and that's 135. Okay, sine 135. Okay, back to today's work then. Okay, 0 to 90 to 135. Okay, we've then got an acute angle of 45 degrees. We're in the sine quadrant. Sine is positive in the sine quadrant. The acute angle is 45 degrees. Sine 45, pick that out, your exact values, 1 over root 2. Let's try another one. Let's go for tan 5 pi over 3. Okay, so pi radians is 180, pi over 3 is 60 degrees. Okay, pi over 3 is 60 degrees, times that by 5, that's 300, tan of 300. Okay, let's get the cast diagram going. Okay, 0, 90, 180, 270, 360. Okay, 0, 90, 180, 270, 300. Okay, we're in the cosine quadrant. Tan is negative in the cosine quadrant. And my acute angle is 60 degrees. Tan 60, got your exact values. That's root 3, so it's minus root 3. Okay, let's try one more. Let's go for cos 5 pi over 6. Okay, so, right, pi over 6 is 30 degrees. Now, how do I know that again? Well, if I work from this base, which is pi is 180, well, if you divide that by 6, you do get 30. So pi over 6 is 30, multiply that by 5, and that is 150, cos 150, go to the cast diagram, and there's 150. Okay, I'm in the sine quadrant, cos is negative in the sine quadrant, and my acute angle then is 30 degrees minus cos 30. Cos of 30, what's that? That's root 3 over 2, so it's minus root 3 over 2.